Hi everyone. In today's lesson, you're going to be learning about the chain rule. And so this whole chapter is all about using the shortcut rules for differentiation. And in the last lesson, we looked at the constant rule. The derivative of any constant is always going to be 0. And we looked at the power rule. We would take the exponent, multiply it by the coefficient of the term, and then we would subtract 1 from the exponent. So those were the first two rules we took a look at. Today we're going to be looking at the chain rule, and the chain rule can seem a little overwhelming at first, but once you get used to it, you'll understand that it's going to make your life a lot easier. And so officially, this is what the chain rule looks like, and I think that probably looks a little crazy to you. What that's saying is if we have f and we have g of x as the inside function, to use the chain rule, we would take the derivative of f and multiply it by the derivative of the inside function, which is g. I think at this point it would be good to look at a simple example to give you the main idea here. For example, it says find the derivative of this function. So we have an outer function essentially that's u to the fourth. If we kind of replace this whole thing with u, right? And if we were to just take the derivative of u to the fourth using the power rule, we would get 4u to the third. But we know that this value we're calling u really has more to it. It's 3x squared minus 5. So what we would have to do then is multiply by u prime, all right? Multiply by the derivative. All right, so we have 4 times the coefficient, which is 4, and we subtract 1, which is 3. So that's this part right here. That's what we have right here. And now we're going to multiply by the derivative of the inside of the function, u prime. The derivative of the inside is going to be 2 times 3, that's 6. 2 minus 1 is 1. And the derivative of a constant is 0. So what do we end up with when we've used the chain rule here? We have the derivative of the outside times the derivative of the inside. Now that is a lot easier than just taking this guy and having to multiply it all out using either the distributive property or the binomial theorem. That would take quite a bit of time. Instead, we could just use the chain rule, and that's made our life a lot easier. So this is just going to be one of the many shortcut rules that you're going to learn to find the derivative, as opposed to using the limit definition of a derivative. All right, we're going to look at a bunch of examples. Obviously, you don't have to watch me do all of these, but I would say try some on your own when you're ready, and then always come back to the video to check yourself. All right, so we're going to use the chain rule here. We don't want to multiply out 3x squared minus 2 to the 5th power. That would take forever. So we're going to use the chain rule. Y prime is going to be equal to the derivative of the outside, 5. We have 3x squared minus 2, and 5 minus 1 is 4. That's the derivative of the outside part of the function, right? We have 5 times 1, that goes here. 5 minus 1 is 4. And we just leave the inside just the way it was. Now we're going to multiply by the derivative of the inside, the derivative of the inside. So we have 2 times 3 is 6. 2 minus 1 is 1. And the derivative of the constant is just 0. So we're really done. We're just going to make that look a little nicer. I'm going to do 6 times 5. That'll give me 30. I still have that x there. I'll write that first. You don't have to, but I just think it looks a little nicer this way. And that would be my final answer. All right, let's try another one. Derivative of the outside first. So y prime is equal to, we're going to take negative 5 times 1, that gives me negative 5. 5x to the 5th minus 2, we don't touch the inside yet. And minus 5 minus 1, that's minus 6. And now we'll do the derivative of the inside. We're going to take the derivative of this guy. 5 times 5 is 25. 5 minus 1 is 4. And the derivative of negative 2 is 0. So we're done. We just want to make that look a little nicer, and we don't want to leave negative exponents in our answer. So to clean that up, I'll do negative 5 times 25. That'll give me negative 125. X to the 4th. And I'm going to put that 5x to the fifth minus 2 raised to the negative 6 power. If I put that in the denominator, I can remove the negative in front of the exponent. All right, and we're done with number 2. All right, number 3, y prime is equal to the derivative of the outside. So we have 1/2 times 1. It gives me 1/2. We're not going to touch the inside. 1/2 minus 1 is negative 1/2 times the derivative of the inside is going to be 8x. We don't want to leave a negative exponent in our answer, and we also can divide 2 into 8. That'll give us 4. So let's rewrite that answer. We end up with y prime is equal to 4x over 4x squared minus 3 to the 1/2 power. All right, with number 4, you may want to rewrite it to just recognize that when we have a radical, it really means the same thing as writing it to the 1/2 power. And we need it in exponential form in order to use the chain rule shortcut. So I'm going to rewrite that first. Now I'll go ahead and use the chain rule. 1/2 times 1 is 1/2. 1/2 minus 1 is negative 1/2 times the derivative of the inside, 2x. We'll clean that up. 2 divided into 2 is just 1. And we don't want to leave a negative exponent in our answer. So we're going to end up with x over x squared minus 1 to the 1/2 power. All right, for number 5, in order to use the chain rule, make it easy for myself, I want to rewrite my radical form in exponential form. So I'm going to have 3x to the 5th minus x squared raised to the 1/5 power. If my index is 5, I can write that to the 1/5 power. Just like in number 4, my index was 2, it was a root 2, it was a square root, then I would write that to the 1/2 power. Now we can take the derivative. 1/5 times 1 is 1/5. Rewrite the inside. 1/5 minus 1, which is 1/5 minus 5 over 5. That gives me minus 4 over 5. And the derivative of the inside. 5 times 3 is 15. 5 minus 1 is 4. And then 2 times minus 1. And 2 minus 1. All right, and we just want to rewrite that without the negative exponent. All right, that takes care of number 5. Number 6. 7/3 times 1, that gives me 7/3. 7/3 minus 1, that's 7 over 3 minus 3 over 3, that gives me 4 over 3. And now we'll multiply by the derivative of the inside. 2 times 4 is 8, 2 minus 1 is 1. 1 times negative 6 is negative 6. And then we'll have 1 minus 1, we'll have x to the 0 power, which is just 1, so we'll have minus 6 for the derivative of the second term, and then plus 2 is a constant, the derivative of a constant is 0. And that's it, we just leave it like that. There's nothing to move, we don't have any negative exponents, there's nothing to really simplify, so we're done. All right, number 7. I'm going to rewrite number 7 just slightly. If I'm saying we're over 2, it's the same as saying I have 1/2 as my coefficient. So now I'll use the chain rule. Negative 2 times 1/2, that gives me negative 1. Negative 2 minus 1, that's negative 3. And the derivative of the inside, so the derivative of 5 is just 0. And the derivative of negative x, that's going to be negative 1. And x to the 1 minus 1, that's just to the 0 power. Remember, anything to the 0 power is 1. So we end up with this term being just negative 1. And if we simplify this now, we have negative 1 times negative 1, a positive 1. And then this minus 3 means that we have to go from the numerator to the denominator to make that exponent positive. So we end up with positive 1 over 5 minus x cubed. Number 8, we don't have to rewrite anything. It looks like it's in pretty good shape. 1/5 times 5 is 1. Rewrite the inside. 1/5 minus 1, so that's 1/5 minus 5 over 5, that's minus 4/5. Multiplied by the derivative of the inside. 3 times 2 is 6. 2 minus 1 is 1, and the derivative of minus 6 is 0 because minus 6 is a constant. Now we have a negative exponent, so we want to put that in the denominator. All right, and we're done with number 8. First thing I'm going to do with number 9 is I'm going to rewrite it in exponential form. So we have 4x plus 2 to the third power. And since it's the cube root of that, that means we would write it as raised to the 1/3 power. Now that's kind of nice because when we have a power to a power, we multiply. So we have 3 over 1 times 1 over 3. I can simplify that even further to be y equals 4x plus 2. And now we'll just take the derivative of that. So we get y prime equals 4. That's it. All right, moving on to number 10, we're going to rewrite it first. When we have power to a power, we multiply. So we're going to have 2 over 1 times 1 over 3. So I'm going to further simplify that to be y equals 3x minus 2 raised to the 2/3 power. Now I'm ready to take the derivative. Y prime is equal to 2/3 times 1 and 2/3 minus 1. So that's 2 over 3 minus 3 over 3. That gives me minus 1/3. And the derivative of the inside, the derivative of 3x minus 2 is just 3. If we simplify that, 3 divided by 3 is just 1. And we have to move that 3x minus 2 to the negative 1/3. Since that's a negative exponent, we have to move that to the denominator. All right, for number 11, it doesn't look like there's anything we can simplify to start, so we'll just go ahead and take the derivative. Negative 5 halves times 1, that's negative 5 halves. Rewrite the inside. Negative 5 halves minus 1, that's negative 5 halves minus 2 over 2, that's minus 7 halves. And then the derivative of the inside, we'll have negative 2x. Negative 2 minus 1 is negative 3. Negative 4 times 6 is negative 24. And negative 4 minus 1 is negative 5. All right, the first thing that I'm going to do is I'm going to move this guy to the denominator so I can make this exponent positive. And then my last step, I'm just going to put all these guys in the denominator and rewrite it one last time. All right, and that's pretty much as far as we can go with number 11. And last one, number 12. And so you always want to make a really good habit of first looking at it and seeing if there's any way we can simplify it. We couldn't really do anything with number 11, but with number 12, it looks like we can simplify the inside because they're both the same base raised to the same power, so we can combine them. So what we end up with is 4x to the negative 4 raised to the negative 7 halves power. So that's going to be a lot easier to work with. All right, now we'll take the derivative of that using the chain rule. Negative 7 halves minus 1, that's negative 7 halves minus 2 over 2, that's minus 9 halves. Multiplied by the derivative of the inside, it's going to be negative 16x to the negative 5th power. So this 4 is tied to this exponent, so we can't really touch that, but we can multiply negative 7 halves times negative 16, and that's going to leave us with 56. And then I'll move x to the negative fifth to the denominator, so that would become x to the fifth, and I would move the 4x to the negative fourth, so that's 4 over x to the fourth raised to the 9 halves power. And that's it. We're done with number 12. Okay, everyone, that's all I have for this lesson. I hope you enjoyed using the chain rule. Have a great day.